In this video, we're going to talk about different types of sensors that can measure displacement. So displacement can be either linear displacement or rotational displacement. So the first type of displacement sensor is a potentiometer, and basically a potentiometer's resistance is a function of its position. All right, and that position can be either rotary or linear. All right, so an example of a linear potentiometer is a dimmer switch for a light switch. Okay, there's rotary potentiometers as well, but they're very the major thing that you need to know is the resistance is a function of the position, and that change in resistance could be used to change an output. All right, in the case of a light switch, change the brightness of the light. All right. For the second type of sensor that can be used to measure position is an LVDT. So a or a linear variable differential transducer, and how a LVDT works is it has a voltage is applied, all right, to a coil, all right, and that coil creates has a will have a surrounds um, a cylinder that has a shaft going through it, and as that shaft moves in and out of um, the cylinder, it creates a change in magnetic field, which creates a differential voltage or output voltage. Okay, all right, and that output voltage is proportional to the position of the core within that cylinder. So, all right, um, so for both, there's linear examples of this, and there's rotary examples. But in both cases, there's a small linear region. All right, or there's a linear region which is used by the sensor to determine the output of the output from the it is used to monitor the position. Um, so for so basically, all you need to know is that for an LVT, the position would be equal to some calibration constant, all right, times the output voltage. All right. So, um, some common vendor one common vendor for LVDTs is RDP ElectroSense. You can look at their website here. Additional vendors, you can look up a list of vendors on ThomasNet. Um, so, all right, and then another way to measure uh, the last two types of measurements we talked about, potentiometers and LVDTs, use analog voltages, um, and those are proportional to position of the sensors. But the next couple of types are called quadrant encoders, and these are digital signals. All right, so they don't provide a continuous displacement. They give us displacement at finite points. Um, and how encoders work is that typically they have a read head, all right, and then they have a scale, all right, so they can have both linear, rotary, and rotary scales and read heads, and as the read head moves or the scale moves, the values of two signals, two square waves, will alternate from on to off. All right, so the two signals are typically denoted as channel A and channel B, and they are offset by 90 degrees apart from each other. Okay, so as the as the read head moves, or the scale moves, basically the channels will go from on to off, and they'll be offset by 90 degrees. So each time we have a rise in a signal or a fall of a signal, the position is considered changed. All right, and by determining the order of the rises and falls, we can determine whether the motion is going in one direction or another direction. All right. Um, so for linear encoders, we can define the position, all right, using this formula here, where we define the number of rising and falling edges, and the number of pulses per inch. All right, and xn in this case is typically equal to the type of, if we're measuring every single rise or fall. So sometimes people are only interested in rises, which would just be x is equal to 2, or the rises of a single system, which would be just x is equal to 1. All right. So, um, so the next page talk about rotary encoders. So for rotary encoders, it works very similarly. Um, the rotary position is basically a function of the number of edge counts times um, divided by x and n, where x is typically equal to 4, measuring both rising and falling edges, while n is equal to the number of pulses generated per shaft revolution. All right, and then that's multiplied by 360 degrees to convert the number of this is basically here is essentially a percentage of the of a revolution traveled, or a fraction of the revolution traveled, and then multiplied by 360 degrees to get the amount of rotation. All right. There are devices now called absolute encoders, and absolute encoders, instead of sending a series of pulses, will send a signal that will tell the motor controller exactly where the motor is positioned, or the stage is positioned. So the nice thing about that is that when you power up that system, or the system turns off, you don't need to do a homing movement or anything. So it knows exactly where its position is, and that's much more convenient than having to rediscover where the zeroing point is. Right. So this is just a brief introduction on linear and rotary encoders. There's a good reference through NI's website on it, so please look it up and read more about linear and rotary encoders. All right. In the next video, we'll talk about velocity measurements after we talked about position measurements.